So welcome to this podcast. Today we are joined by the Professor Rama Kant, FNA FAS, a senior professor in chemistry at Delhi University. He earned recognition at national and international level in the various fields like electrochemistry, polymer physics, and complex system. Also, he has worked with the Nobel laureate Professor PGD Guinness, and also he has given more than 200 fundamental equation in the electrochemistry. आज हम सर से बात करने वाले हैं और जानेंगे इनकी रिसर्च एंड एकेडमिक जर्नी, और स्पेशली जो स्टूडेंट्स इस फील्ड में अपना करियर बनाना चाहते हैं उनके लिए ये वीडियो काफी इंफॉर्मेटिव एंड काफी हेल्पफुल रहने वाली है। पॉडकास्ट शुरू होने से पहले चैनल को सब्सक्राइब जरूर कर लेना, एंड वीडियो के एंड में आपका जो भी फेवरेट पार्ट है उसको कमेंट बॉक्स में जरूर बताना है। एंड नेक्स्ट गेस्ट आप किसको सुनना चाहते हैं, किसको देखना चाहते हैं, उनका नाम भी कमेंट बॉक्स में जरूर बताना। सो लेट्स स्टार्ट। सो हेलो एवरीवन एंड वेलकम टू दिस वीडियो। सो इन टुडेज वीडियो आवर रेस्पेक्टेड guest Professor Rama kant sir, a senior professor in the chemistry department of Delhi University। आज हम सर से जानेंगे रिलेटेड टू केमिस्ट्री डिपार्टमेंट, आपके करियर से रिलेटेड, इलेक्ट्रोकेमिस्ट्री एंड काफ़ी टॉपिक्स से रिलेटेड हम बात करेंगे जो कि मैंने आपको इंटर में बताया था। सो स्टार्ट करते हैं। सो वेलकम टू द वीडियो सर। सो फर्स्ट ऑफ ऑल योर ब्रीफ इंट्रोडक्शन टू द स्टूडेंट्स जो कि आपसे कनेक्ट कर पाएँ सर।
आई एम प्रोफेसर रमा कांत, currently working with Department of Chemistry, University of Delhi, and my journey, scientific journey, starts from my school age in a sense, where you start dreaming first about it, that you want to do something different from other people, or you want to pursue a scientific career. So at that time you put your imagination according to your knowledge at that time, and you read a lot of things to get motivated by biographies and scientific content, various disciplines. In particular, in my case, I was reading more physics at that time when I was in school or college life, and dreaming about practicing science in my future life as a scientist or a professor in university or institution. So I used to play a lot with the electricity and chemicals in my childhood, doing some water splitting and those kind of experiment raw with the facility available at the home also. Sometimes used to do more dangerous things also or something.
Just like all students and kids.
Yeah, so used to take risk, etc.
Okay.
And then I joined Rajdhani College for my honors degree in chemistry. So and that was a college thing, and I used to write articles about various concepts and issues in science, like arrow of time and those kind of physics, because I have somehow bias toward physics, though I was doing chemistry honors.
It's interesting.
So I used to write for Wall magazine of my college at that time, and even wrote some article in, there was issue like I think Junior Science Digest or some kind of magazine was there on chromatography and this kind of article. Just as when you are young, you want to do something.
Yes,
want to. And then I came to university after completing college and did my masters from chemistry department, where currently I am professor. And from there I went to IISC Bangalore to do my PhD, because I always thought I should go to the best institution, because that can only provide you best training. That was my decision at that time. And I happened to join one mathematician, his name was Professor S.K. Rangarajan, who turned into an electrochemist.
Okay.
So it was another thing. I was doing chemistry degree and more interested in physics. And then I went to a person who is doing mathematics but solving electrochemistry problem. So I dreamt myself doing only analytical kind of theory, which means more mathematics type of derivations and theory. And he was most appropriate person for me, because he was sitting in chemistry department. He was doing that kind of theory, not computational. Lot of people theory when you mention in chemistry, it is computational chemistry dominated by. So there I realized that to do that kind of theory, I have to learn a lot of mathematics. So I practice a lot. I have my hostel, sitting in my hostel room, my research lab. So first 3 years of time I invested only learning mathematics.
Mathematics.
Because I knew I want to do theory of that kind.
Okay.
Chemistry, I have enough knowledge, and whatever physics will be required, I will read.
Yes, yes.
So then I decided there was area like fractals or something. Fractals are objects which can be described in terms of fractional dimensions.
Yes.
You have heard about 0 dimension, 1 dimension, 2 dimension, 3 onward. But fractals for objects or something like tree, clouds, all those geometry you cannot describe in terms of integral dimension. So the fractional dimension concept comes there, and the object which has that property are called fractals. So I used to read a lot about those things. So as a student, I was reading all sorts of things related to theory, both biophysics, what are problem there, or a physics problem, what are there, or mathematical physics, what are mathematical techniques to solve problem. That way I learned a lot of things during my PhD. And my PhD supervisor was a very liberated person, so he didn't force to learn, do this or that. And in a process, while I was doing PhD, he became director of Central Electrochemical Research Institute. So when your PhD guy becomes a director, he doesn't have time for you. So you have to do things more of yourself. So I took that as a challenge.
Okay.
And I started learning, then mathematics, and then I thought, okay, I will solve electrochemistry problem which involved rough boundaries, because when you make electrode, any solid electrode, it has a roughness and it influences all electrochemical property. There is applicable to battery, sensor, or all field actually.
Okay.
These are the fundamental aspects of electrochemistry. Fundamental knowledge can be applied to any applied system.
Okay. Means, sir, you have explored all the platers: physics, chemistry, mathematics, even little bit biophysics.
Yeah, I used to read thinking used to dream I will do some problem, research problem
In
there
physics,
also.
chemistry, and mathematics.
While doing PhD, I have a lot of ideas, thinking, but everybody has finite time, so you have to focus in one.
Okay. So what main thing inspired you to stuck for the chemistry field, and mainly in the electrochemistry and polymer field?
Okay. First thing, some of our journeys are not predetermined. Like I was more interested toward physics, as I said.
Yes.
So I got marks which were suitable only for chemistry department.
Okay.
In the college. So I joined there, but I started enjoying there because that also has a lot of quantum mechanics, chemistry type of field.
Yes.
So somehow I just started enjoying that.
Okay.
And but my love for mathematical theory remained with me. So when I became PhD, I preferred to do theory in that way.
ओके सर, अगर सर अभी हम आपको चांस दें दोबारा से पीएचडी स्टार्ट करने का, आप कौन से सब्जेक्ट में स्टार्ट करना चाहोगे?
Basically, I prefer to work in a field where less crowded are there or less manpower is available. Okay. So although I did my post PhD study with a lot of physics department people or chemical engineers also. Okay. When I was out of country into France, Britain, Germany, and USA. After doing even theories in physics department, I worked with Professor P.G. Dijen. He was Nobel laureate in physics, and soft condensed matter and those kind of things he did. He is well known for his classic scaling concept in polymer physics.
Yes.
Or something. It's a very popular book used by, because of mathematically it is less complicated doing scaling theory. So it's more popular among experimental people also.
Okay.
And So thing is about okay, what you will like to do. I will like to do theory, and there's a thing I told is that I prefer to do electrochemistry because there are less people available to solve this kind of problem in electrochemistry. So I'm only one in this country, and we will all over world also there are few people who does this kind of theory for asking problem of electrochemistry with complexity at interfacial region and the solution, etc.
Okay, so you are the like rare element in the chemistry, but you are the rare professors in the chemistry in this field.
Yeah, so way I do my research is very different from other or average chemistry person.
Okay, sir. Moving to the next thing, sir. Could you share a little about your PhD journey at IISC and your postdoc research experience in France and the UK?
So during PhD, our lifestyle was that we will used to work because IISC has a good ambience. So you are living within the campus.
Yes.
So you can work late hours also. So I used to work late hours actually, 2 a.m., 2 a.m., 3 a.m. or something. So sometimes you want to get obsessed, you will solve this problem, then you will go to your hostel or something. So I used to work late in night. Then sometimes it will not get solved and you walk back to your department. So at that late in night, you will see only some outlets sitting on the road.
Okay.
So you, if your problem is not solved, you feel like you will lose or something. So that was the fun. But anyway, you have to keep thinking, keep solving, and keep learning more. Because first thing, though, you have to have skills. Whatever area you want to work, as many as a skill you have, more flexibility you will have in solving your problem.
Yes, yes.
Because first you have to formulate interesting problem, challenging problem, which that field really needs. And then you, if you realize that there are not many people who can solve that, then you have advantage of solving them more even.
Motivation.
Yeah, motivation. And also sometimes people, lot of people come say, oh, I was working in this problem, somebody else has solved the same problem and published.
Yes.
So if you are working where area is not crowded, you have less of those kind of threats.
Okay.
And so, also you are solving thing which you know ki unlikely they will come to literature unless you work on that.
Okay. So very challenging, sir.
Challenging.
Okay.
Prefer that way.
Okay, sir. Next thing is looking back at your student days. What qualities do you feel were most important in shaping your career?
Basically, you have to read a lot. Even when I was sitting in my undergraduate or I used to go to science library of our Delhi University, and I used to browse a lot of books there of various fields, quantum mechanics, statistical mechanics, that were much ahead of my required for my syllabus or coursework. So I used to read and prefer to read classic book over the, sometimes students Indian authors are easy, but I will go look in the back of the book and see which is most cited book. So I will go and start reading that book.
Okay, challenging yourself.
Challenging yourself.
Okay.
Those will be usually classics of that area. So.
Okay. So connecting to your research, sir. Sir, your research focuses on electrochemistry on rough and porous electrodes.
Yeah.
Okay, sir, could you explain in the simple terms why these systems are so important in modern science and technology?
See, when we form electrode, so we want to increase the electroactivity. So one way is to, you have to enhance the area of that electrode, because it is directly proportionate to electrochemical current to the area of the electrode.
Yes.
So in the process of increasing area, you end up making more disordered, more rough and porous geometry.
Okay.
And but what happened, whatever fundamental laws are given in textbook of electrochemistry, they deals with the idealized surfaces, assuming they are smooth or plane.
Oh, yes.
So when you try to apply these laws into the real practical or technologically relevant or scientifically relevant electrochemistry, those does not capture it completely or something. So therefore need to make that. But problem with that, they make mathematically very complicated problem. Like you have a boundary, or you are solving a partial differential equation with a random boundary. So it's like solving a differential equation in a stochastic boundary or something. So solving those problems, there is no exact solution available in the even with mathematicians or something, or applied mathematics field. So you have to come with lot of clever approximation, which will be good enough to capture the physics, chemistry of the problem, but should allow you to move further. Because if you are stuck with a problem which is not solved or soluble earlier, you have to find a way out. So either you have to use mathematical approximation, or you have to use your physical intuition, what is important, what is not important, to simplify your problem. So it is said that like a smart or scientist is the person who knows how to make good approximations.
Okay.
So if you can do that, you will be able to capture physics or chemistry of your problem within a simple equation instead of having stuck with the equation.
Okay, most of the things work on approximation.
Yeah, because I prefer to solve analytically instead of going to numerical methods.
Yes.
So end of my each work is some equation, as you would have studied during your college and master's level.
Okay, yes, they are the higher levels.
Yeah.
Okay, so next thing is you have developed more than 200 fundamental equations in electrochemistry. How does such theoretical and advanced eventually benefits experiment devices or even industries like batteries and sensors?
Most of the work I have done myself. I do some experiment also to know what is seen in experiment, which I have to capture in my theory. With that knowledge, it gives me distinct advantage when I am making approximation there, which I say it is very important to find a clever solution of your problem.
Okay.
So I know what is visible in experiment. So I keep track of experiment, sometimes do myself also, because other people will do experiment as they imagine that field. When we do that experiment, we will say how to capture that physics, chemistry of my observation in experiment into my theoretical equation. So we do that kind of things.
Okay, sir, if a student start in this field, how can he start in this field?
One can start in any field. You have to learn as much as possible.
Okay.
Don't be miserly in learning. Read as much as you can read.
Okay.
Practice, like particularly if you do mathematics based theory, like which I prefer, you have to learn a lot of mathematics. For which you have to mathematics you can learn only by practicing it. Pencil, paper.
Okay.
So when I was PhD student, I used to get big computer sheets from computer center. They have for printing matrices, etc. They have extra large size sheets.
Okay.
So I used to practice my mathematics on the back of that. So I accumulated a lot of such sheets. It was worth enough to make a mattress in my lab or something. I have one bamboo sofa without mattress, so I put those sheet over that, and when I'm tired, I will lie down.
Use as the matrices.
Yeah, because sometimes you will do mistake, and then you will throw those sheet.
Yes, yes.
But sometimes you realize no, you did it correctly, so you don't want to throw away your sheet immediately.
Maybe
so that you can go back and use that
maybe use in the future.
Yeah.
Okay. Oh, sir, I am adding in this. Sir, if a student not really interested in mathematics, can she be successful in this field?
Yeah, electrochemistry is dominantly, or even polymer science, is a lot of experimental work is there. These days, most of the people who are practicing material science or electrochemistry or energy science, they are working on electrochemical problem only. Because there's a lot of experimental, challenging, neat experiment has to be done to design your electrode, design your electrolyte, so that you can get optimal response from your, say, in battery or any device or a sensor. And you have to optimize their cyclability also. It should be stable response for a long time. When you make a device, you have to make it chemically stable, electrochemically stable, mechanically stable, and cyclability of the device. It should reproduce thing which you are expecting, not changing response every cycle or so.
Okay. So next thing is what role do polymers and electrochemical systems play in a new age technologies such as energy storage, sensors, and biomedical devices? If you want explain in the simple word so that the UG, PG, and PhD students.
Most of the biosensor, whether glucose sensor, you end up making some interface, and either through enzymatic reaction you do over the electrode surface, and then sense them through electricity, actually electron transfer, etc. process. So same in the battery, same in the other field. And the relevance of this is that we are doing this thing and having a just mobile phone and with enough energy to run at least 24 hours and more.
Yes.
It is the lithium ion battery which is running it.
Yes.
All our laptop is not possible if there is no lithium ion battery.
Yes. Yes.
All this portable device became popular only after the invention of lithium ion battery. So electrochemistry is everywhere. Because all this plating we have on our wristwatch or a jewelry, etc.,
yes,
that is electrochemical in nature. Even our brain function on the ion transport, etc., our neural system. So it is all electro. So whole consciousness itself is a electrochemical cell. Combination of that, because brain itself is so many neurons are there.
Okay, interesting. So, okay, next thing is, for students interested in theoretical chemistry and simulation, what skills should they start focusing on?
One is if you want to there are usually two type of theory done. One is computational intensive, one is mathematic intensive. If you are comfortable with practicing a lot of mathematics, then you can do that kind of analytical theory based. Or you can go for computational based, then you have to be good in programming also. Programming language.
Coding.
Coding. And some people do in lighter version is software based. People who have already converted knowledge into software and using those software to calculate various molecular and material properties, estimate them by that. So there were various type of thing. A lot of people who are interested in practicing chemistry without wetting their hands, theory is one of them.
Okay. So mathematics and coding is the most important.
Yeah, these are the things. Plus, knowledge of chemistry and physics is always required.
Okay. So how do you see the role of interdisciplinary sciences like physics, chemistry, materials in shaping the future of electrochemistry research?
Yeah, electrochemistry basically it combines various fields. Material is very much there when we form new electrode, both cathode, anode, electrolyte. These are all material only. So you have to cast this material in such a way by either making nanomaterial, nanostructure over the electrode surface, so that you can get optimum response and optimum stability in it. So material comes that way. To understand this material behavior, you have to know the physics of that or something. Because whenever you make a device, there is a problem of wetting. So that has to be, because you are putting electrolyte solution with another solid material. So if your surface is not very good wetting property, it will not give you good electrochemical response. So people who are interested in devices, they think in all respect wetting and then optimizing material, then their electrochemical response, their electrochemical stability, then cyclability. Because any device you buy, it costs you money. You will like it to run for larger and larger cycles.
Yes.
So for that you have a supercapacitor other than battery which has million type of cycle. Your battery which have 10,000, 12,000 cycle or something.
Okay.
So we have to want to improve them further, because improving them further means you are paying less cost and more worth for the device.
Yes. Okay, sir. At starting, you have mentioned at your childhood you have do very experiment dangerous and something. Sir, आप एक experiment या फिर कोई ऐसी अपनी कोई story share करना चाहेंगे जहाँ पर आपको लगा आपने ये वाला experiment किया और ये वाला experiment तो काफ़ी dangerous, या फिर आपको उससे parents से भी डांट लगी हो?
Parents usually I was living in Arkepuram area which has government flats.
Okay.
I used to perform these experiments through my stairs, that gap where electricity, I used to break the switchboard and get the electricity. So a lot of time parents are not aware what I am doing there. Particularly in summer breaks or so, I will pass my time that way. Sometimes generated hydrogen, etc. Definitely hydrogen, if it generated in large quantity, it can be explosive.
Yes.
And then water, this thing. Sometimes I didn't have even tester, so I will touch my finger to see which one is phase, which is neutral.
Okay.
So I've done all those kind of things during my teenage also.
Okay, sir. Interesting and very such are dangerous.
Yeah.
Too dangerous.
I will not suggest other people.
Okay.
So use safety tools.
Okay. So, okay, next thing is, if you had to explain electrochemistry in one line or in short to a first year BSc students, how would you do that?
Electrochemistry originate when you have interface. So interface is must. Wherever you have interface, there will be electrochemical phenomena. Interface can be metal, it can be some conducting polymers, it can be semiconductors, it can be semi-metals. So whenever you have such system, you have electrochemical phenomena. And there is a kind of, when you have such system, because there is energy difference between interface and the solution, so there will be aggregation of some ion at the surface, and that aggregation of ion in electrochemistry we call electric double layer or something, or it gives you non-Faradic kind of response, more like charge organization. And there's another response when you have electron transfer, it is called Faradic response. Some of you are anyway familiar with Faraday laws or something.
Yes, yes.
So Faradic response will follow Faraday law, and non-Faradic will not follow.
Faraday laws.
But they have, both are important, because non-Faradic people do make devices like called supercapacitor, which has capability to discharge large quantity of energy in a short time. Battery does not have that capability. That's why both are important. If you want large quantity of energy, but you can do it low power, then battery is better. If you want high power, and so then time you have to combine with the supercapacitor or something.
Okay. Okay, so next thing is, across your research journey, was there a surprising or even funny lab research moment that a student will enjoy hearing?
Yeah, we in experiment we get sometimes surprises. Like we do electrochemical experiment. We did this one in absence of tube light and one in presence of tube light. It shows difference in their response.
Really?
Yeah, it difference come because there is metal has some roughness and there is a activation of surface plasmon.
Yes.
So surface plasmon does influence the effective work function of metal, and that is shown in the electrochemistry responses.
Okay.
So this is like one way surprise, and so we started doing theory for that. And similarly, like once my student, we were making theory for supercapacitor. So there was some very nice experiment occurred in basically science journal or something.
Okay.
So, and they showed that when you have very fine pores in those things, it is like metal carbides. You remove metal there, you will have carbon matrix, and it showed very anomalous property when pore size became very small. So we were doing theory for particularly ion reorganization, and then suddenly the data was showing opposite behavior. So the equation which we derive, my student changed the sign of that equation because it was representing capacity in terms of curvature of the local curvature of the surface, and then data fitted. And while I was having in my slides with the opposite sign, if it is data with different sign, then it occurred to me when I realized, first I was shocked here, change the sign. Then I realized this other response is because the curvature which is outside material has, inside material will have opposite sign. If it is convex outside, inside will be concave. So the sign will change there.
Yes.
Then I realized it will be due to some electronic phenomena, like electronic capacitance of my material. So then we started looking into new field of electronic capacitance of material. That helped us a lot because we then could develop many fields out of that. First we did electronic capacitance, then we went to how work function get influence of material by the curvature of the local curvature of the material. It helped us to account atomic steps, roughness on my metal surfaces, etc. In nanomaterials, how curvature influences the thing. how the size and there is a like plasmon activity, so how it is related to that lambda max there. So all this theory emerged because of one mistake by my student, and we cashed on that mistake by realizing this is not coming from my electrolyte solution side, it is coming from the electrode side, and which will make that sign opposite to that, plus becomes minus in that situation. So we looked into theory, what people say about, and we developed like gallium based theory in our approximation, which we have used extensively to explain our electron transfer theories, potential of zero charge on electrode surfaces for very complicated electrode geometry which nobody has ever touched earlier. So we are able to ask questions which were earlier considered to be tough enough not to touch us. So that was the advantage of this way. Yeah.
Okay, sir, you find new things by mistakenly and working on them.
So whatever you mentioned, 200 equation, it comes because of solving various these kind of problems.
New things, finding
mass
new
transport in rough electrode, porous electrode, electric double layer in rough electrode, porous electrode. These are all very mathematically difficult, so nobody touches them.
Okay.
So we have distinct advantage all over the world to solve this kind of problem.
So
it happens because what I did first when I was doing PhD, I started first building mathematics for this kind of system. That gave me tremendous advantage. The mathematics developed there can be utilized for so many problems actually. There were many approximation, surface roughness based expansion, boundary expansion, perturbation theory, then curvature perturbation theory. So these kind of problem mathematics which we developed, which was not there to how to do it for electrochemical context, it helps to ask many questions where mathematics we knew we can map it.
Okay. Sir, you have worked in India, also in France and UK international work. So what are the basic differences and similarities you find at international and Indian level?
See, on an average, all people, whether you are in India or a Nobel laureate I worked with, and then one FRS I have worked with, so they work also very hard. It's not only they are bright, but the people are bright if they are getting Nobel, but they work a lot, very hard. So you have to give a lot of hours. Still I give sleep around 1 a.m. or something because I will be either working on some calculation or editing manuscript or something.
Okay.
So you have to give a good amount of time. So practicing science is not 9 to 5. You have to give your maximum to it if you want to do good science.
Okay. And what are the differences between the students, their mentality, their interest, and their hard work of international and Indian students?
Here we are more scattered, so we dissipate a lot of time in tea shops and chatting with each other. There people they take their, like Europe particularly, weekend break and go for skiing or some other activity. But during the weekdays they are very focused on something. So overall efficiency is higher. We invest more hours, but we blow off also many hours.
Okay.
So if you have more focus, you can achieve thing in much shorter hours.
Okay.
Or whatever you are, if you are very smart, clever, it's fine. If you are not, if you keep persistence in your work, knowledge, whichever, and keep pushing the front, because one day you will get success.
Okay, means Indian students, or generally we are the students, are busy in this field but not very productive.
Yeah, that's why you have to read a lot first. You have to increase your imagination power. For that you have to read somebody else's work. So broader you read, as I did during my particular PhD time. Before that I was also reading this, since you are from physics background, special theory of relativity.
Yes.
I learned all those things sitting in public library at Delhi public libraries are there. No? So in Sector 8 we had that library. I will sit there. So I have used all libraries available around my home, Delhi University Library, Central Library, particularly in summer time when you are totally free, classes, bondage is not there. Or public library when I was in a school or something. Or even IIT Delhi Library, because you look like a student, you walk in confidently, nobody will stop you. So
Exactly.
that I used to do, read mathematics there because they have good collection of lot of mathematics book. So some book may not suit you, but other book will be more, you will find
Yes,
your
yes.
frequency matching with that, you understand that pattern. So you have to read as much as possible and
Okay.
have focus in your life. So don't scatter your energy in many directions. Keep in one direction, then you will achieve success also.
Means more focused.
More focus because
Okay. So one thing you want to change or you can change in Indian students or Indian education system, if you can change that one thing.
okay, in an Indian education system, first thing to people should be given more opportunity to self-learn. It's not about only acquiring marks. You have to acquire knowledge because when people are looking for you, or if you are looking even for employment, people are looking for your skills, not for your how many marks you obtain your degree. With that, they will judge you by interview, etc. How much you know about the thing.
Yes.
Sometimes people just take marks and forget knowledge. So knowledge is more important than marks.
Okay. Okay, so almost last. If a students tell you, sir, theory feels too abstract and tough, what motivational advice would you share with them?
Uh, Basically, nothing is tough. If you invest time with the thing, you learn it, and then it becomes friendly to you.
Okay.
If you don't give time, anything will be tough for you.
Yes, yes.
So wherever you will give time, you will do that well.
Okay. So give
So
time to that.
you can devote time, you will learn it.
Okay.
If you feel you are weak, you practice more, you will become better.
Okay. Okay.
So nothing is impossible except you have to give your time for that.
Okay. So last thing is, sir, could you share your 3-point success formula for the students in a short time?
Working hard is very important.
Okay.
And having focus in life is very important. You cannot keep changing your track again. You will reach nowhere.
Okay.
And wherever you can learn.
Okay.
So don't ignore anybody if you can. See, as a student, when I was doing PhD, we used to in maths discuss with computer science people,
Okay.
physics people. They were all sitting one beside you.
Yes.
So though that field is not of your direct interest, but that way also you acquire a lot of knowledge.
Yes,
Or
yes.
even while reading paper, I used to read. If you read introduction of lot of paper, lot of science you learn by that because sometimes they write better than a book also.
Yes.
In a very short time, if you want to work less and learn more, you read introduction of papers.
Okay.
Because there they will try to say a thing into much shorter work and very precisely they will give you the right
Okay.
thing
In
into your
short, a
head.
new thing
Yeah.
you will learn. Okay, sir. That's all for this. So, anything you want to share to the students, or any story of yourself, any motivational, or anything you want to share to the students, to the public? Your PhD time, your school time,
Okay,
anything else?
student who are looking to join research as a career, first thing in that is you have to find your guru correctly.
Okay.
If you end up with a wrong guide, you will teach you less and you will waste more time.
Okay.
So find something who is very knowledgeable, who knows well. Then only he will be able to teach you.
Okay.
So you should not feel that within 1-2 year you become like your as knowledgeable as your guru. Guru should have so much knowledge that
Difference will
when
be
you
there.
leave him, still you feel he knows a lot.
Okay. Difference.
So
will
that
be
is very important. Sometimes institution matter, but it's not that all like popular institute, all good people are there. Every place has some good people, some middle level people, some bad people. Only you have to opt which is good for you, and because you are going to invest long time for PhD, about 5 year or
Yes.
something.
Yes.
So opting a person whom with you will like to invest 5 year is very important. So he should know a lot of things about his field, so that you learn also
Okay. The
maximum, and that is very accelerated learning because person would have invested 25 year, 30 year, 35 year to understand thing, which will be transferred to you very directly, and you will get you will be thrown in the middle of that ocean of knowledge.
Yes.
Because he know how to swim, he will make you also swim in that.
Okay.
So that is very important.
Okay.
Finding your right guide and teacher.
Right teacher, right mentor in the life.
Right mentor in life.
Okay, so that's all for this. So thank you so much for watching this video. Thank you so much, sir.
Thank you to you and your audience.
Okay. सो थैंक यू सो मच फॉर वॉचिंग दिस वीडियो। होप करता हूँ वीडियो आपको हेल्पफुल लगी होगी। अपना फेवरेट पार्ट वीडियो के कमेंट बॉक्स में जरूर बताना एंड नेक्स्ट गेस्ट आप किसको सुनना चाहते हैं उनका नाम भी आप कमेंट बॉक्स में जरूर बताना। वीडियो हेल्पफुल लगे इसको लाइक जरूर कर देना एंड यस आपका कोई भी डाउट हो आप उसको कमेंट बॉक्स में लिख सकते हैं या फिर मेरे को यहाँ पर इंस्टाग्राम पर मैसेज कर सकते हैं। थैंक यू सो मच, मिलते हैं अपनी नेक्स्ट वीडियो में।